Good morning. Today's lesson 3.2, linear relations. Alright, so today we're going to introduce some buzzwords, some terms, some looks that you will see moving forward in mathematics. Different teachers, different textbooks, different courses of study as you move along. Alright? So the first one I would like to introduce you to is this one. Y alpha, the Greek letter alpha, x. Basically, you read that as y varies with x. Okay? So the alpha means or signifies varies with. Basically, the alpha can be replaced with equals m. Now, most teachers will say equals k, but because we're doing linear functions, I'm going to do equals m. So now that equation looks like this. All right? Okay, so let's continue on. How can you spot a linear function? Well, the first thing is you look at the x and the y. And those exponents on the x and on the y are powers of 1. Any other power. Okay, oh, I forgot to mention, sorry. Powers of 1 means that the equation will be known as a first degree equation or a degree of 1 for the equation because the power is 1. All right. Any other degree, any other power, the graph will no longer be a linear graph. I challenge you to try downloading or going on to desmos.com, punch in any equation you want. Don't go too crazy, okay? As long as you have different exponents, you'll see that it stops being a straight line like I said. All right. Now, as far as we're concerned, we are mostly going to use what we call y equals mx plus b. Now, the proper name of that is the slope-intercept form. Slope-intercept form. Reason it's called that? The m is the slope, and the y is the y-intercept. So the slope-intercept form. Okay? All right. Now, two basic types of equations, linear equations. The first one is direct variation, where y varies directly with x. Now, we've seen this. For example, y equals 2x. There's your equals mx. You'll notice that there is no b factor, no extra piece. That's what makes it a direct function, because it's the y and the x directly working together. No extra play. It can have a fraction as an m or a negative, doesn't matter. Okay? So basically, it has a direct action from x to y. There's no other piece involved. Okay, you're going to notice that when b is absent, the line will always go through 0, 0, also known as the origin of the graph. Now there's a reason for this. It goes through the origin because to have b disappear, in math talk, that means that b is equal to 0. It's still mx plus b, but nobody bothers to write, for example, y equals negative 7x plus 0. Okay, they just don't bother to show the 0. So in this case, the b is there, but 0 makes it look hidden. Again, use Desmos, take a quick look, punch in a couple of examples that have with 0 and with a number, and you'll see that the graphed line will move to the origin and off the origin. Anyway, if there's a direct variation, then the next part we need to discuss is partial variation. Okay? So y will still vary with x, but being partial, there will be an extension. There will be a plus minus extra piece. Here is where the b has to be a number other than 0. Okay, so if you take a look at the first equation, y equals 4x minus 1. The b is negative 1. The b turns out to be the y-intercept, and I will talk more about that in 3.3, okay, section 3.3. But what does that mean? The y-intercept means that the graph is going to go, or is going to cross the y-axis at -1. Okay, one more example. Y equals -2/5 x plus 3. So the y-intercept is going to be at the location on the y-axis at +3, as you see there. Okay, and then the rest of the graph will pan out. All right, so that's the lesson for 3.2. We'll see you soon.